People love working here, not only because it's a very lean and mean team, very senior people, but also because the product is so cool. I mean, you're out there and everyone knows what that is that you've worked on.
It's been 8 years since we launched our last console. We were super excited over the last few years to work on something new. And the living room has changed a bunch in the last 8 years. People are streaming, they're hooked to the cloud. People are doing more than just watching TV. They have their laptops, they have their tablets, they have their phones. We wanted to build a box that took advantage of these trends, that allowed developers and people developing experiences to be able to use all of these things and have them available in one box.
Hardware is an emerging portion of the company. Microsoft has committed itself to being a devices company and recognizes the need to be vertical to compete in that space.
In today's world, you want to build something that's specific to your vision, to your inspiration. And you can't go out there and just get a set of commodity parts to do that and get it in the right form factor.
It's not something that we can just go into a silicon company and say, hey, we'll use this part number from you. It doesn't quite work that way. So we have to build things from the ground up. So we're building a system. We're not a silicon company. We're a system company, devices company.
And silicon is a part of that. And one of the challenges early on for both Nick Baker and I was to explain to Microsoft what silicon is, the long lead time, the investment required, what people's roles are, why we were hiring these people. And we've essentially built that up over the last decade.
The heart of the Xbox is our system on a chip. It has the CPU on it, the GPU on it. We have embedded SRAM, which is a very high bandwidth bus that allows us to keep the GPU compute units always full and always processing data. So we're really excited about the performance that brings. We're developing really two OSs, one for the applications and one for the games. And so now you have the ability to be able to switch back and forth instantaneously from an application to a game, from an app to a game to television to Skype. We can actually snap two things at the same time on the screen and you can have them side by side. No one else has done anything like this in the living room. And it's really because we have such a great software background at Microsoft and we've done this custom silicon work that we are able to do things like this.
There are 3 custom chips in the console. There's a large SoC that we've talked about. There is an I/O chip, a Southbridge chip, and there is a chip in the disk drive that handles DSP and other functionality. Those are the 3 on the console side. On the sensor side, we've got 2 chips. One, the key heart of the sensor itself, the custom imager. And that's the chip that we've developed completely internally and is based on a custom pixel and an array and analog circuitry around it that exists nowhere else in the world. Not to say anything negative about the processor and the Southbridge and these other components, that the challenges that we faced there were quite high and the team has done a great job on all of those. But this is something truly unique, not just within Microsoft, but in the industry.
We've done a bunch of IP in our new Kinect sensor that no one else is doing. We call it time of flight.
This Kinect technology, look, this technology that we are introducing now based on time of flight, it's a better and wider field of view. We have more resolution, more pixels. We can see more people, more bodies in the field of view. It can fit better to more living rooms than the previous Kinect, smaller rooms, larger rooms. It can fit people with different heights and the different frame. It can see more poses. It can see small people, young people, and taller people interfere together. The resolution, as I said, is much better. You can see finger, you can see poses. Then on top of it, we have ability to see more your expressions, your engagement, your face. This is because we have active IR as an outcome. And we use it. This is actually sort of a monochrome vision or 2D vision of the world, which is completely resilient to the ambient light.
We have designed the Xbox with the future in mind. On the box itself are a number of ways for us to connect to the internet and connect to other devices, and we believe that as you connect to these other devices, that's going to create this ecosystem. Xbox Live will be there, and all the game developers and all the experience developers know that they'll have the power of the cloud at their disposal. And with that, they'll be able to do additional compute on the cloud, they'll be able to have persistent worlds on the cloud, they'll be able to save games to the cloud, they'll be able to use the cloud in addition to what they have on their box.
We purposefully did not target the highest end graphics. We targeted it more as a broad entertainment play and did it in an intelligent way and focused on key aspects of the IP for that.
If you look at how we are bringing the ability to not just play games, but to do entertainment and the next generation of natural user interface that we're bringing here. Having that and looking at some of the experiences, or even imagining some of the experiences that you could do with that is pretty incredible.
It's not the first time that Microsoft has done a chip, and the people who are here have clearly done them before, and we've done them within Microsoft before. But this is one of the more strategic plays. In terms of the overall product, that is a clear differentiator, and the IP that we've developed here is truly unique.